I welcome you back to this series on algorithms analysis and design. And in this video, we are going to talk about Kruskal's algorithm. So we already know that this particular algorithm is used in order to get the minimum cost spanning tree for a given graph G. So in case you want to revise the concept of spanning and minimum cost spanning trees, there will be a video showing up in the I button. I suggest that you first go and see that particular video and then come back to this particular video in order to obtain a minimum cost spanning tree using Kruskal's algorithm. So as far as the Kruskal's algorithm is concerned, there are primarily two different steps. So in the first step, what we are going to do is, we already know that the graph will be weighted graph, right? So in the first step, what we are going to do is, we are going to arrange the edges in increasing order of their weights. So whatever the different edges are, we will be sorting them in increasing order of their weights, and then we will start with a forest having no edges, and then we will consider adding edges in increasing order of their cost. So one thing that you must have noticed by now is that I have written the word consider. What does it mean? It basically means it is not necessary for us to be adding all the edges. We will be adding only those edges that ensures connectedness of the graph and that does not bring about a cycle in the graph. Only those edges are going to be a part of minimum cost spanning trees, and rest other edges, they will be completely ignored. So for example, let us take a problem. We are given this particular graph which is there on the left hand side. Okay, so we can see that this particular graph is having 7 different vertices labeled A through G. So A, B, C, D, E, F, G. These are the 7 vertices which are there in this particular graph. So these vertices have been put in the vertex set. Likewise, there are 10 different edges that have been put in the edge set E. Okay, so in the first step, what we are going to do is, we are going to sort all these edges in increasing order of their weights. So this thing I've already done. You can pause this video and verify it yourself. Okay, so after all these edges have been sorted in increasing order of their weights, my step 1 is complete. So in the step 2, what we are going to do is, we are going to start with a rand forest and we are going to add edges one by one, while ensuring that the addition of a particular edge does not lead to a cycle. Okay, so let us try to find out if I can add the edge fg. Can I add this edge fg? Yes, because it is not leading to a cycle. So I will add this particular edge and I will also be writing the weight of this particular edge above it. Okay, so what about the next edge, ae? Can I have this in the graph? Yes, I can have it in the graph because it is not leading to a cycle. What about b comma f? Yes, again this edge can be there in the subgraph. What about cg? Can I have this edge? Yes, I can have this edge because again it is not leading to a cycle. Okay, so cg has been added in the subgraph. What about the edge ef? Can I add this? Yes, I can add this because again addition is not bringing about any cycle. Okay, what about bg? Can I have this? No, I cannot have this. Why? Because the moment I choose to have edge bg also, then it would lead to a cycle. So this edge is going to be ignored. What about CD? Can I have this? Yes, I can have this because it is not leading to a cycle, right? What about edge AB? Well, I cannot have AB because the moment I add AB, there will be a cycle ABFE. So this edge is going to be neglected. What about GD? GD can again not be there in the spanning tree because it will again lead to a cycle GCD, right? So this edge is neglected. What about the edge BC? Can I have this edge? No, I cannot have this edge because again it would lead to us this cycle, right? So this edge is again neglected. So whatever result we are getting on the right hand side, this is my minimum cost spanning tree. Why is it a spanning tree? Because it is connected, it is having all the vertices as in the original graph, and it is also not having any cycles. And why is it minimum? It is minimum because we have considered adding edges in increasing order of their cost. That is why the result we are going to get is minimum cost spanning tree. And what will be the cost? The cost of this particular tree will be the addition of all these edge weights. So 2 plus 3 plus 2 plus 1 plus 2 plus 4. This will be my cost of this spanning tree. So this is the minimum cost spanning tree that we have obtained with this cost. Okay. So I hope you have understood how to use Kruskal's algorithm in order to solve this problem. Okay. So with this we now come to the end of this short session.